All right, good afternoon, ladies and gentlemen. Welcome back to another live stream. Sorry for the super short notice. I was not actually planning to do a stream today, but I had the time and thought it'd be fun. Again, thank you to everybody for all the well wishes regarding because last week I mentioned or last live stream I mentioned that I was going to have some skin cancer removal. It was successful. And I'm doing pretty well now. And so part of the reason I didn't stream the other day is because I still had a bandage on my face. So unfortunately, I do still have a bit of a scab on my face, but I'm healing well. Just to give you a little so we're going to continue with our Wordle clone Python project today. And if you didn't attend the last live stream regarding that, basically what this project is doing, it's not a machine learning effort as opposed to all the other stuff. This is really just kind of a fun project to help teach people the basic principles of Python in a use case that's easy for folks to understand. And so if you didn't have the opportunity to check out the previous live stream, it is available over on YouTube. Actually, all these live streams, because I simulcast on LinkedIn and YouTube, so the YouTube ones are always saved for later viewing. So if you ever have to miss any of these, don't worry, they are over on YouTube for you. So just to give you a heads up on the other projects that we're doing, so we are still continuing working through our movie rating models project. Excuse me. So where we're at with that one is, basically everything's done. I'm just trying to create a little web UI that I want to host out on a platform called Heroku, and so that will wrap up that project. We still have the computer vision parking lot project, and that one's still coming along. I just need to do more research on that one before I'm prepared to do another live stream on that. And then, if you all are connected with me on Instagram, I shared this morning that I'm going to be beginning another project around natural language processing. So specifically, it is looking at what I'm referring to as ticker tweets. And so if you're not familiar with what a ticker is, so if you think about like a stock, stocks get a symbol, and so like Apple's, for example, is AAPL, Tesla's is TSLA, and so you have these ticker symbols. And what people don't realize that on Twitter, or some people don't realize on Twitter, is that you have your hashtags, which are signified by the little pound sign, and then you can click on that and see more information in the hashtag. But with the ticker symbols actually work the same way on Twitter. It's just that you put the $sign and then you put the ticker symbol, and then you can actually look at all the tweets using a ticker symbol. And so that's actually pretty popular amongst financial users over on Twitter. So I thought it'd be fun to create a natural language processing model that analyzes sentiment analysis of tweets, just to see it's a fun project. I would never consider myself a fiduciary in any capacity, so do not take the model's word that we're going to be building for it. But the question I'm wondering is can we build a predictive model that will analyze the sentiments of a certain category of tweets each day to analyze a positive or negative sentiment about the market for that particular segment, or even as a whole, or even just for a narrow stock. So like what I'm basically thinking is, we'll start with one stock. So like we'll take Tesla stock, for example, and see what the sentiment of Tesla stock is. And then maybe you might bundle that together with a grouping of technology stocks. So you might have Apple, Google, Twitter, any of those, bundle them all together to get a general sentiment about all those. And then you just keep expanding out. And then you could do the whole NASDAQ or whatever. So more to come on that. I do, a lot of these live streams I just am continuing to learn things myself as I go. So that is another one of those where I need to do more research. And so today I'm honestly, I'm not even technically prepared for today, but I do feel like I am skilled, like I have enough skill to be able to talk through what we're going to do today. So and enough waffling, let's go ahead and have me share my screen here. Okay, so what we did and where we left off here. Okay, so what we basically did, and again, this is a project intended for beginners with Python. So if you have no experience with Python, no worries, I will explain things along the way. However, I'm going to try to not reiterate too much what we did last time. But basically what we did here is, this is a text file that I got from somewhere. I honestly don't remember where, but basically this text file has 10,000 English of the most popular English words in it, with no swear words in it. I can't remember what medium stands for. And basically what this is doing is it's taking in this and reading this in as a word list now, and then And then, we have these new line character spaces that we're basically removing from the word list. And so when I check out the word list, and I'll just go ahead and type that in here, then you can see that I get all these different kinds of words here. And so, with Wordle, we just want to get the 5-letter words. And so what this little bit of code here is doing, this 5-letter words code here is saying, okay, for every single one of these words in the word list, we're going to check to see if the length of the word is 5 characters long. And if yes, we're going to append it to this array here. Now, one thing I do want to note is that even though we're going to be focusing on the 5-letter words just because that is how Wordle works, I'm considering that, maybe we can adapt this thing to where you can make it, what's the word? More flexible to what you want to do, meaning that you can have, instead of a 5-letter word, maybe you want to have 6-letter words or 7-letter words or a choice of all 3 of them. So for now, we're going to stick with 5, and then we might, as we continue along in this project, see if we can adapt this a bit further. By the way, I have both my streams for YouTube and LinkedIn open right now, or both my comment IM chats, or IM windows, sorry. I'm tongue-tied right now. And so if you have any questions, feel free to drop them in either one of these. I will be glad to answer anything along the way. So for now, that's what this is doing. So anyway, first bit of code here, just loading in this text file. A reminder. Second bit of code here is removing these new line spaces, and then this third bit of code here is just getting the 5-letter words. Now, one thing I did want to point out is, we are importing something up here, and what import does is basically saying, okay, I think I used this analogy last time. Like, imagine that you get a new smartphone right away, whether it be an iPhone or an Android. Out of the box, you're going to have default apps installed onto that smartphone. So you might have a messages app, you might have a phone app, something like that. But what you're not going to have on there are your custom apps. So I don't think Facebook's pre-installed, for example. So or LinkedIn or YouTube. Well, YouTube might be on Android actually, but let's just use Facebook because I'm pretty sure that's not installed. If you want to use Facebook, you just go and install it, and then you can make use of that on your iPhone just as you would or smartphone just as you would any of the other default apps. And likewise, the same holds true for Python. So Python, you have all these different things that you can do by default with Python, but if you want to enhance the functionality of your code, you import these things called Python libraries. And again, I talked a little about that in the live stream previously. And so one of the default Python libraries that comes with one of the Python libraries that can come with, oh my gosh, I'm saying this wrong. One of the libraries that can come with Python is this thing called random. And so what we're doing here, and I was just demonstrating this really quick, is if we import this random library here, and then we do a random.choice, and we pass in our 5-letter words here, then it will print out it will print out the word here, just randomly grabbed from this bag of words. So let me show this. So we have the 5-letter words here, 5-letter words. Okay, so these are all of our 5-letter words here. And so, what we're basically doing here. So if you're not familiar with what the syntax here is doing is saying, okay, this is what we call a function. And so a function is, very similar to a function in math. And basically what it is saying, okay, in this parentheses here, I'm going to pop something in here and I expect to get something out. So what I'm popping in here is my whole list of 5-letter words. And what I'm expecting to get out is just one word, randomly selected from here. And so that's what this is doing. So, and then the print statement here, this is also another default Python function. It's basically saying, okay, print whatever is the output here. So if I already ran this once, so you can see that we got the word sweet. And now if I run it again, we get the word Korea, least. We can just keep running this over and over and over, and we're going to continue to get a random word each time. So hopefully that makes sense and is pretty straightforward. Okay, now let us move on to figuring out the logic of how we want to address our Wordle word. So if you recall how Wordle works, basically, I don't remember how many tries do you get. Actually, let me look that up. I always forget. Wordle, how many tries do you get? Okay, you get 6 tries. Okay, we're not going to worry about the 6 necessarily yet. What we're going to just focus on right now is see how we can parse through these things appropriately. I got too many tabs open here. Is this the right one? Yeah, I think this is the right one. So I'm going to go ahead and close out these other extra tabs. So basically what we need to figure out here is, okay, when we guess when we guess something, we need to match it to see how we need to check to see how closely it matches the original word. And so what I'm thinking about how we do this is, well, first of all, I'm just printing out the statement here. Let me just go ahead and save this to a variable. Now, again, if you do not remember what a variable is, consider a variable like a container of sorts. So think about like, people have these bunch of empty jars here around the house, like, and you put like buttons or food or whatever in these jars. And like you can, write a label on the jar, and then you could dump out the contents of whatever's in that jar, and then you could refill it with something else. But the label's still going to be the same. So similar to this, what we're doing here is I'm going to say actual word equals random choice 5-letter words. So it's basically saying, okay, I want to assign this here, and then I'm going to print it out. Actual word. Okay, that way we can continue to make reference to this variable later on without but the container is always going to be the same, different. So in this case, right now it's penny. Now it's teeth. Now it's Emacs. But when we actually write this in code and we want to interact with this in code, we don't have to call it Emacs each time. We just refer to this placeholder, if you will, that we call a variable. So I hope that makes sense. Oh, by the way, so in Python, there are different types of variables. And so in other coding languages, you actually do have to set the type yourself. So for example, in Java, you might need to, if you know you are working with an integer, you might need to work with or actually explicitly note that it is an integer, or if you're working with a float value, or if you're working with a string. So in this case, this is a string. And just to show you that, so print, spam call. All right, print type actual word. So this is going to tell us the actual type. So this is a class of a type string. But the nice thing in Python is it does what we call dynamic typing, meaning that when you assign it to something, it's going to do its best to guess what the actual class of the object is. Which makes, so actually, even though I don't use Java myself, I actually learned how to code on Java. And let me tell you, it's a lot easier to learn Python than it is Java because of the dynamic typing. Like the actual, in Java, trying to figure out how to do that static typing, it's just kind of a mess. Not a mess, but like it's just really hard to learn on. Okay, so we have a string type here, and so what I'm thinking that we need to do, I'm trying to think of the best way to do this. So I'm thinking about assigning this to each character to a dictionary value, because we need to keep in mind also. And actually, you know what? I am going to set one of these, the actual word for now, to be a very static value, and there's a particular reason I'm going to do this. So I'm going to call actual word to be, I'm trying to think of a good 5-letter word. I need teeth. Actually, teeth is not a bad example. And the reason I want to use teeth is because, one of the things about Wordle is you can do a guess of the letter, but it might not necessarily be in the correct place. Let me just show you for a really quick example. Well, you can see here right here. So if I guess the word weary and it was incorrect, but like this W, so this W is basically indicating, okay, we guessed the letter correctly, but it is not in the correct spot. And then, so if we come down here, then basically it is in the correct spot. I'm sorry. Basically this letter I here is correct. It is present in the word, but not in the right spot. And then this letter U here is not correct at all. So we need to account for that in some capacity. So I'm thinking about using a dictionary. And what a dictionary is basically a whole list of these key value pairs. And when I say key value pair, I mean that you'll have like a key that you want to refer to, and then a value that is associated with that word. So the way that we do this in Python is we use these things here called curly braces. And so these are curly braces. And then let me just create a my key. I'm going to call this my key. And then we do a colon here. And then I'm going to call it 10 as the value. And then you can do more than one key in a dictionary. So I'm going to do my second key is 20. Okay, like that. Okay, so when I run that, you can see that it's just the dictionary. Actually, let me go ahead and save this to a variable. I'm going to call this my_dict equals that. And so whenever I use my dict here, then I can do this. Now, the nice thing about dictionaries is that, we've got two different key value pairs here, but let's say I knew that I have my dictionary here, but I want to see what is the value of my key here. So the way we do that is we refer to the variable name, and then within these braces here, these are called braces, so a left brace and a right brace, we put in the key that we want to refer to here. So let's say my key. So my dict, my key. Now you would expect this to be what? Number 10, obviously. Boom, and which it is. And the reason I'm thinking about doing this is because then I can create a dictionary that basically assigns how many letters there should be in the word. So like let me show you real quick. So like with teeth, let me do this again. My teeth, or I'm gonna call this teeth dict. Teeth dict equals, and so we have, and I'm just gonna do this statically. So we have two T's, and then so actually this is the preferred way that people write dictionaries, is something like this. So T equals 2, E, there's two E's, and one H. Okay, so I mean we're just this is what we call hard coding our stuff. So we are hard coding our things here because we're not actually doing any sort of code to actually do the count of how many different letters there are and stuff. So we don't want to hard code these for now, or we don't want to hard code these down the road, but for now this is fine because this is just helping us to learn things through. So again, if I reference this teeth dict, and then I say I want to know how many letter T's are in there. We know that there are 2 letter T's in there, and so there should be a simple way to do this. So now I'm wondering. Sorry, I'm a little unprepared, so I'm trying to think, talk, and do everything all at once. Sorry, think, talk, and type all at the same time, which is never a great idea. But anyway, so teeth dict. All right, so I'm trying to think, what is the best way to do this? Oh, I wanted to check to see if there was actual word dot split. Does that split? Okay. All right, so let's Google this really quick because basically I want to see how do I separate all these letters from the word. All right, separate. All right, Python, and so this is how we do it. And just knowing how to use Google is half the battle. And this is the case not even just for coding. I'm trying to do so many things at once right now that I can't think of all this stuff. So most of this week I've actually been doing some graphic design, and so knowing how to Google anything is half the battle. And actually, it's not even just knowing how to Google things; it's just knowing the concepts of what you want to Google. So in this case, I want to Google Python how to split word into letters, and I'm sure there's probably a super simple thing here. Okay, so list. Oh, really? Is it really that simple? Okay. Well, all right, so let's see if this actually works. So list actual word. Oh wow. Okay. Okay, so what this is basically doing, so this is the list class, and it's basically taking our word and then splitting it into a list of all these different letters. And so, these are all indexed at a certain value starting at the number 0. So T is at index value 0, E is at index value 1, and so on. And so, let's say I wanted to reference this 4th letter here, which would be at index letter position 3. I am confusing my words right now. So, all right. So again, so 0, 1, 2, 3. And so it's similar to how we did our reference to, where did I do that? I must have deleted it. Okay, but anyway, it's similar to how we did our reference here. So, we did our teeth dict, and then we referred to by the key. Same concept here. So I'm actually going to put, I'm going to call this list of letters for now. List of letters equals that. And so list of letters, then we refer to of letters, and like I said, we want to get the the 3rd character position, so I'm going to reference the number 3 there, and you can see, boom, we get the letter T. Now if we were to do the 4th index position, what would you expect? the letter H there. Now, one thing I do want to highlight, if you try to do something like this, so this is basically saying I want to get the 5th index position, which does not exist. You'll get an index, you'll get an error, basically saying list out of range. So it's basically saying if you try to refer to something that it does not exist, sorry, you're out of luck here. And so that's just the default behavior of Python. Okay, so the question is there a way to programmatically turn this into a dictionary without us having to do anything? And there is a simple way to do this. So what I'm going to do here is, let me go ahead and create a new cell. All right, so what I'm going to do here is turn this, what do I want to do this? Word, actuals, letters. I'm going to call this actual letters dict equals that. So basically I'm instantiating an empty dictionary here. And then because the idea here is that I'm going to take the word, I'm going to split it out into all of the different letters, and then I'm going to iterate through each of the letters. And then as I continue to iterate through the letters, I'm going to add them as a new entry into this empty dictionary here. And so the way we do that is doing a simple for loop. So the for loop is basically saying, okay, because remember we have our list of, let me print this out here, of letters. So we have our list of letters here. So this is oops, sorry about that. This is a list. So we have 5 different items on our list. And so actually, let me just go ahead and show you. So if I did for letter in list of letters, and I just set colon and then enter key, and I just say print the letter. Now you'll see this is a new line every single time. That's because this is the first time we went through the loop, the second time we went through the loop, and this is going to keep going through the loop until this list is exhausted. So if I come back up to here, I'm going to do a for letter in list. I'm going to do this a little bit shorthand. So letter in actual word. Now what we need to do is create a new dictionary entry if it does exist, or if it does not exist. If it does exist, what we need to do is just increment the value of the key already present in the dictionary. So the way this works is we're going to do a conditional statement. And basically a conditional statement is saying, okay, if you have to do something with this condition, then do this. But if there's some other sort of condition here, then do this other thing. So this is what we call an if-else statement, or an if statement. You'll see what I'm talking about here. So basically what I'm saying is, if letter not in actual letters dict.keys. Okay, so I didn't explain this. So let's say you have this teeth dict down here and you just wanted to see the keys. So the way we can do that is teeth dict dot keys, and what that basically is going to do is saying, okay, I've got 3 different key value pairs in here, T, E, and H. So basically this what this code up here is saying, if this letter is not in this keys thing here, then actual letters dict, and then we are going to create a new entry, and we're going to give it the key of that. And since this is the first time, presumably, that we are seeing this in our little dictionary, we are just going to instantiate it with a 1. Now, let's say we already do have the letter in this dictionary, and again, because the word teeth here has 2 letter T's, 2 letter E's. Basically, what we want to do is, okay, instead of creating one of these, we just want to increment it by 1. Now, the way we do that is else. So basically, if the letter's not in here, otherwise, we want to execute this code. And so what this code is going to do is say actual letters dict letter. Now recall, we're not going to set it to equal 1. We want it to increment by 1. So the way the shorthand to do that with Python is basically saying plus equals 1. Okay, so what that's going to do is it's going to create a dictionary for us that's going to have all these things in here. All right, so let me go ahead and delete all this code down here because we don't need it anymore, just to clean things up. All right, so I'm going to cut that out. Okay, so let me go ahead and run this. Now let me show you, what does actual letters dict have in it? Okay, this should look familiar to you. This is the exact same dictionary that we hard coded earlier, but this time it is different because we are instead using what do we call it? We're using variables here to programmatically do this instead of hard coding all these things. Because basically what I can do here is I can run this here. So we have the word games. And if I were to run that and then run this again, so you can see that we have this dictionary here that says we have one G, one E, one. All right. You know, basically one of each of these letters because that's unique one. So let's see if I can generate. Okay, so this one's got 2 letter I's in it. Run this code again. So we have one V, 2 I's, 1 S, and 1 T. All right. So that part, boom, is done. Okay, now, all right, I'm going to stop talking for a second so I can think, because I can't think and talk at the same time, unfortunately. All right, so, we want to check the T. Okay, because we're going to submit our guess. Okay, so I'm gonna, I'm just trying to think how to do this. So I'm gonna just create a dummy guess called my guess, and we'll do something later on another point where we're actually inputting it dynamically instead of setting a variable like this hard-coded. But let's do a my guess of, I want to do a word that has, where one letter's in the right place and then something else is not. So how about the word, is the word serve? No, I'm just trying to think. What about the word guess? So that's got the E in the right place, yes. But I want something else that's, how about the word search? So E is going to be in the right place. A-R-C-H, nope. Wait, no, the H is going to be in the correct place as well. All right, so I'm trying to think of something that, I basically want a word that has 2 letters, one that's exactly in the right place and one that's not in the right place. And so I'm trying to think of a word that matches along with teeth that kind of simulates that. So... And I'm just looking at the words on my bottom screen here. Apple. Does apple match? No. I don't know. S-T-R-E-A. No, that's... so what about swear? Swear? All right, so we got E-S-W-E. Yeah, so that's right. A-R. I don't know. Why can I just not think of something? Heats? Meats? M-E-A... No, because that one's got... why can I not think of a word? Oh my gosh. How about learn? L-E-A-R-N. All right, so E matches. L... No. Gosh darn it. Well, this is hard. Okay, so... Hold on, let me think. Short? I'm just... Short. Okay, so S-H-O-R-T... Okay, no, that's not going to work. Local. No. I am literally just looking at words around my cloud. No. On my phone and stuff. All right, today. All right, so T is in the correct place. There. Oh, okay. Well, all right, this will work. I mean, well, there. Yeah, no, I don't like this. TH. Well, I need a better word than this. Okay, come on, think. All right, does anybody have any suggestions? If you have any suggestions of a word where you have one that's in the right place and then the one that's correct but not in the right place and the others are all incorrect, please give me an idea. Because this is kind of I can't believe I can't think of a word here. All right, I'm just gonna Google words that start with TH. Words that start with TH. All right, how about thick? Will thick work? All right, so THICK. All right, thick will work. All right, here we go. So thick is basically saying, okay, I've got these correct letters, but not in the right place. Okay. So, I'm basically going to be doing a direct comparison of each letter here. So for, I'm trying to think here, what is going to be the easiest way to do this? My guess. All right, so for letters in list my guess. Okay. I might just have to code this, and then I'll go back and explain this all because I'm having a hard time. Clearly having a hard time just thinking and talking today. So, yeah, let me see if I can do this. All right, so for letter in my guess, if letter... Okay, because I need the original... list. Print letter. Okay. Sorry that you are... Why is... Oh, is it still trying to key off my old word here? Okay, there we go. Alright, so if letter and actual letters. And then maybe I need to do 2 for loops. For... if for actual letter and my actual if actual okay final result equals okay, so if the actual letter equals the guessed letter, then append or final result append where's that? Where's the green check? Or not green check, green box. Green box. Final result. For actual letter. Okay, but that's because that is, I'm not removing for letter and actual letters. Okay, and I can't pop that out. Okay. Okay, so let me go ahead and talk you through what my logic here right now is and why it's not exactly correct. So basically, I am creating an empty list here that is going to hold the final result. So assuming that when this is working, we're basically going to return back a thing that says, okay, you got one that's correct in the correct place, and then the other ones, like basically it's going to be the green, the yellow boxes appropriately returning all these things. And so you could see that it's returning 3 green squares, and this is not correct because basically what I'm doing is I'm iterating through the letters of all the actual, like, so, you know, I'm basically iterating through all these letters, and then again iterating through all the letters of my guess of thick here, and then saying, okay, if the actual letter matches the guess letter, and so that's the... So one thing to note with Python is you'll see that we have the equal sign and then the equals sign. The single equal sign is really just an assignment operator. And when we mean assignment operator, we're basically saying, okay, we want whatever is on the right side over here to match up to this over here. So that's not actually doing like a comparison. However, like this is actually doing a comparison over here. So this is basically saying, okay, does this actually equal this? And then likewise, if we wanted to do a not equal, so we do it like that. Okay. But and the reason it's not working is because we're iterating through every single letter every single time. So it's basically not removing the letter appropriately once we've already seen that. Okay, so we want to iterate through all the actual letters, and then we need to remove the letter if there is a match from the actual list. And so the way that we can do that, and because this is going to be a little bit of a problem, and then we want to break the loop, or no, continue the loop. Okay, continue. Yeah. All right. So okay, so I need to actually create another variable here called my guest letters. All right, so I'm gonna call this guess word just for consistency. Guess word guess letters equals all right. How do I remove something? All right. Okay, I want to test something out here. All right, actual word equals teeth. Actual test list equals okay. No, because that won't work. Okay, dot pop t. Okay, that's not gonna work like I hoped. Dot pop. All right. Okay, so we basically need to remove this from the list. Well, does that matter? Oh, I guess it doesn't really matter. Okay, so how do I find the first T? All right. All right. So Python. Move first. Move one. Oh, okay. Interesting. Oops. Keep accidentally pressing that thing today. All right. So test list. Okay. 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 I know this is not a very fun live stream to watch because you're just watching me think, basically. Because, like, it's not that hard. It's just, like, I know there's a way to do it, and I'm probably overthinking it right now, but, like, I'm basically trying to figure out, like, what's the best logic to do here. So, okay, so let me go ahead and explain what I'm doing here. All right, so as I noted, for each of these letters, so the guest letters here, guest letters, we have each of these 5 letters, and then if I did, like, an index value of that, we get the T. So what this len operator does is, so it basically gives you the length of how many values there are here. So there are 5, 4. Oh, am I doing this right? So 4 index len guess. Oh, range, that's right. Okay. Okay, there we go. So basically I'm saying, all right, so there are, this length operator is basically saying, okay, how many letters are in this list? So we have 5 letters. And then the range is basically saying, okay, range, all right, it's basically giving me a list of values up to a certain, like, range here. So if I just did down here a range of 5, you would see that it gives me a range of 0 to 5. And then if I did I'm curious, what if I did a list of that? Then yeah, you get a list of integers like that. Okay, so basically, and I want to use these to iterate through everything. So I'm going to do a range length of those. All right, and so what I'm doing here is then I'm looking at the actual letters. So for the first part here at least is for the actual letters at the index value and the guess letters. If these two match together, basically saying, okay, if the actual letter and your guess letter matches perfectly, then let's append on a green square here because that's indicating it's a correct letter in the correct place. And then what I wanted to do here is guess letters index equals, I was going to basically turn this value into well, what do I want to turn it into? I don't know. For now, I'm just going to call it -1. All right, so let's see the result of that. So final result, and then parent guess letters. Okay, so you can see here we have 1 that was actually in the correct place, and then we have a -1 where there was a value there. So, and the only reason I got just a placeholder of a -1 here is when this is all said and done, I want to ensure that, you know, if, all right, so, okay, yeah, so if H is there, okay, so once this is done, now we need to get the yellow letters. And the way we get the yellow letters is for... All right, so we basically want to go back there and iterate these. All right, so for... All right, let's go ahead and do this as a separate thing. And again, I apologize that this is why I try to pre-prepare for these live streams, is because I want to be able to, you know, not have a whole lot of dead air. And this is probably the live stream that's had the most dead air by far so far. So sorry about that. Yeah. Well, let's keep going on for now. All right. So basically, we do have the actual letters dict. Okay. Okay. And then actual letters dict. Let me reset that. Okay, so this is what I'm basically doing here is, so, you know, we append we appended the green square on here, and basically what I was doing in here was seeing if I could refer to the dictionary value here, because remember, we have our actual letters dictionary, and so in this case we'll have two letter T's, and so basically this is basically a placeholder that references that letter T, and so that's why in our output here when we print we see the number 2 because there are two number T's. And basically what I want to do is decrement this here, and so the way we do that, similar to how we increment it up here, is we just do a minus equals 1 equals 1. All right, so let me go ahead and run that again. And so then we run this, when we run this dictionary, you can see here that we have remaining, actually I'm going to call this remaining letters dict. Remaining letters dict. Okay, let me go ahead and kernel restart and clear out, because sometimes it's good to start fresh on this. Okay, so yeah, that might be smart. All right, so then the remaining letters dict. Okay. Okay. Oh, okay, I got an idea. What if I just instantiated this with a range list range of 5? Why did it not? Oh, that's because I didn't reset this. Okay, but I don't want to append now. All right, so final result index. Come on, key. All right. Okay, this is working as I would have hoped. All right, so we're instantiating the characters. Out of curiosity though, I wonder if this actually would work. All right, so Python. All right. Okay, I like this better. I like this syntax because basically this is going to have just empty strings. All right. So what this little bit of code here is doing is it's instantiating a list of empty string values like such. All right. Okay, perfect. All right, but if it's not there, then we skip over. All right, so else. So this is the square that represents that nothing is there. So that's just doing a direct comparison. All right, and then if I were to do another iteration through here, or okay. Yep. All right, sorry, I'm just trying to think through this here. All right, so what this is basically, what this bit of syntax here is doing is saying, okay, right now I'm saving everything as a -1 value if it's already like removed from the list, if you will. And so what this continue statement is basically saying, okay, is I'm good to go here. So just, there's nothing else to do here, so just continue on to the next iteration of the loop. Now, if we were to actually use the different keyword called break, that would actually break out of the loop entirely. So if it saw, for example, this -1 here, which is the very first letter there, it would go ahead and break out of this loop entirely, and which is not what we want to do. We would prefer to use the word continue in this case, which basically continues the loop. Okay, so well, I don't even remember how the guessing thing works here again. Okay, so let me just final. Alright, so there is an L, but it's in the wrong place. Oh, okay. Alright. So, else, if guess letters index equals if oh wait, no, I don't want the, I want if result. Okay, so I don't think I even need to do this -1 baloney. Okay, which I did not think I needed to do. Okay, I think I'm getting somewhere, folks. thank you for sticking with me. All right, I think I'm finally getting somewhere. All right. All right, so if it's guess. Okay, so we want to decrement again. All right, so final result index equals the yellow square, yellow square, and then we want to do all right, so final result, and then we want to decrement this. So that is going to go -1 minus equals 1. Okay, I'm curious now how well this code's going to run. All right. Where do I have I at? Key error I. Okay. Oh, I don't see. My struggle here is not the Python code. My struggle here is just trying to think through this logic, like, because I keep mistaking what I'm trying to do here. Because this is actually not too bad as far as Python logic goes. It's just I'm just being really stupid right now, trying to think through the actual logic of this Wordle puzzle here. Because basically what I'm doing is, so this first bit of the code here again is just handling the precision thing. So if we get a precise letter, then we're good to go. And then the other one is just trying to fill out the rest of the letters appropriately. So yeah, I actually do want to do that. So guess letters. Well, I guess do I even need a final result? Maybe I don't even need a. Well, let's keep it here for now. Let's keep it here for now. Index equals also the green square. And again, I'll put. Okay, maybe I don't even need a final result. Okay, okay. All right, we're getting somewhere, folks. We're getting somewhere. All right. Okay, I wonder if this is actually going to work. Key error. Why would that be a key error? All right, so. Oh, yeah. Okay, there we go. All right, I think I finally got it. I think I finally got it. And let's see. No, that did not work. Okay, I actually do think that did work. And let me explain what it's doing here. And I'm just rereading the code one last time. Okay, so we don't need this after all, and we don't need this. We don't really need that. Well, I wonder if we could just consolidate this now. All right, if now I'm curious. Let's go ahead and comment this out. All right, okay. This is actually all the code. All right, I figured. sorry, like I just had like a total brain fart. So let me go ahead and explain what's going on here. Okay, so as a reminder, what we're doing here in this cell. Actually, let me go ahead and rerun all these cells again. All right, so I'm going to rerun these cells. All right, remember our actual word is teeth, and then our guess word. Let me go ahead and move it up. Is going to be thick. So in this case, we're going to have the T is in the correct place. So after this guess, we're going to have the first place is going to be the green square. And sorry, I got a little bit of allergies. That's where I got a little bit of stuffiness right now. So sorry that I keep sniffling. Actually, let me go blow my nose real quick. I'll be right back. Okay, sorry about that. I'm back. Okay, so where were we at? All right, so what we were basically doing is, all right, so I'm going to annotate this with some comments. Do I even need to have an actual letters? You know what, I'm going to put this code down here. I'm going to start annotating this. All right, so by the way, annotations. What are annotations? Annotations are basically comments on your code that in Python they begin with this the pound sign or hashtag symbol, whatever you will. It's basically telling the machine, okay, ignore this. This is just human readable code that helps us to understand things. So I am very diligent, very diligent about annotating my code, because later when I come along, I want to be able to read this in plain language and understand what it's doing. Okay, so here is I am creating a dictionary that holds how many letters are in how many letters match to what am I trying to say here? My problem here is not actually the Python. The Python here was actually pretty simple. My problem here is that I just cannot think straight today in terms of the actual logic of what we're trying to do. All right, so we're creating a dictionary here that holds how many remaining letters are necessary for the actual answer. Okay, so that's what we're doing here. And so let's go ahead and run this cell. Actual letters for a list in actual letters for a list in actual word. All right. Oops, didn't mean to do that. All right, so here we're actually creating lists of letters from each of the actual respective actual and guess words. So okay, so what we're doing here is we're taking the actual word. So this is just my actual word here. Let me go ahead. I'm gonna go ahead and create this as one cell. All right. And again, we're not trying to create any sort of dynamic thing that's actually doing the comparison. All right, so setting static variables for testing purposes. All right, because it's always nice to have a test case, so we have those. All right, so then we actually create the list of the words from each of these actual words. All right, so, and just to make it really clear, we're going to print all right. Now I can't remember if I explained this last time. Hold on, let me do this. Also letters. Okay, what I'm doing here is what we refer to as f-string formatting, and is basically saying, okay, I want to print something out into the console, and but when we get to this actual part here, I want to actually print out the variable here. So the way we do that in Python is when we actually run the print statement, we typically put our stuff in quotes, single or double quotes. It doesn't really matter here per se. And then, but when we start this thing with the letter F here, then when we put our variable in the curly braces, it will print out appropriately instead of this actual variable name here. So when I run this cell, you can see here letters in the actual word is teeth, and then the letters in the actual guess word is thick. So THICK, TTH for the actual answer. And so here, performing logic to match the guess to the actual word. Okay, so what we're doing here is, okay, so this is, again, you know, there is we're extracting how many letters are in this this list object here. So we have 1, 2, 3, 4, 5. So that is what this length operator is doing right here. Then what the range operator, or what the range function here is doing based off of this input here, is basically saying, okay, I'm going to give it the number 5, and so I'm going to produce a range of values between starting at index 0 all the way up to index value 4, because you know we have 0, 1, 2, 3, 4, and so that's a total of 5. And so we're iterating through the for loop here. And then, so for this first part, we are performing action appropriate action if the I'm missing a piece of logic in here. I just realized that LF. Well, I guess in this case I could just basically say else. Okay. All right, sorry about that. So performing the appropriate action if the guess letter matches the actual letter. Because, so we're basically going through here and checking all these one by one. So basically saying if this T matches this letter T, which it does here, then we are going to give, we're going to turn this in the guess letter here into a green square, and then we are going to decrement this from the actual dictionary of the remaining letters. Actual letters index. Yeah, so that's right. And then otherwise, okay, I did something wrong here. All right, or I made it overly complicated. Overly complicated. All right, yeah, I made it overly complicated. LF. Okay, yeah. Yep, I messed up here. All right. Well, I didn't mess up, but I just wrote it weird. Okay. And then I need to alter the indentation there. Okay. All right. So if it's not there. Okay, I wanna, yeah, I'm doing this in a weird, funky order. This will make sense here when I clean this up. Sorry, it's kind of a mess right now. All right, so in this first, because we're basically creating a conditional statement, and we're doing a couple different things here. So basically, this first one is saying, okay, if there's a precise match, then turn this this square here green, and then decrement the value of this index position in the remaining characters dictionary. This next one is basically saying, okay, if the guest letter here in this index position is not at all here, then we're going to turn this into a square, a gray square. And then the next one here, we need to handle the situation where performing appropriate action where letter is correct but not in proper position. Now I feel like I'm confusing it again. I think it was working already, and I think I tried cleaning it up, and it just made it all messy again. Yeah. And then just to be safe. Well, yeah, let me go ahead and, because I think there's nothing else important in here. Oh wait, no, because that's not gonna work right. All right, just thinking through here. All right, so because I don't know if this will handle it all or if not. I got an extra print there. So I need to basically copy this. me just think through this whole thing here again one more time real quick. All right, so basically what I'm trying to do here is iterating through all the individual slots, and so if it's correct, we get a green square. If the letter's not correct at all, it gets a gray square. If the letter's correct, but we've already hit our quota as far as like, we can't turn it into a gold square because it's already been accounted for previously, we turn this into a gray square. And then for our final cases, if it's correct and it's right in the right position, and we still have a remaining letter index quota available, then we turn it gold. So I think this all works. I know this is, that's really hard to think through, but the Python's pretty simple. So like let's walk through the bits of the Python here. Okay, so we already talked about the for loop and then all this other stuff here. So apologies if some of this is a bit of reiteration. So in this first, let's talk about this if statement here. So basically, we have what we have here is a different series of conditional values, and this is going to be worked on from top to bottom. So basically the code here is looking to see, okay, does our code satisfy our first condition? And if in the first condition it does satisfy, then we run this code, and then it does not run any of this other code. But let's say it does not satisfy this first condition. Then we go down to the next condition, and we check on this condition. And if it doesn't match and then if it does match this condition, we'll run this code, and then we'll continue along. We will not run this other code down here, and then so on and so forth. So if again, if for some reason we don't hit either of these conditions, but we do hit this condition right here, then we run this code, and then we skip this code all down here. And then finally, if we run through all these conditions and our code does not meet any of these conditions, then we'll run this here. And if this does not work, then nothing happens at all. So, but let's say we went through all of these conditional statements and none of the conditions were matched, but we still wanted something to run. That's where we use this else if keyword and performing in case the conditionals don't work. So, actually, no, I don't want to do that because, let's say we did have something where, our code didn't meet any of these conditions. Well, you just run, is this else block? And this is kind of like the default thing. Like, so basically saying, all right, if we don't hit any of these conditions, just run this code here at the bottom. But we don't want to do that because, let's say we just did arbitrarily assign the index value to be this. Well, then we could be deceiving ourselves. Like, because what if this code up here doesn't work? And that's what I'm trying to think through is does this actually work all right? I'm pretty sure it does. But if it doesn't work right, then it would be more preferable to throw an error than something that was false. So in this case, we will actually not have an else block. So those are the conditional statements here. So I'm going to go ahead and delete all that out. And then, what we're looking, all right, so we talked about the first condition. So the second condition here is saying, okay, if this letter here, so in this first position, if the letter T is not at all in this remaining letters dictionary, we just give it the empty space. So like, let's say, we guess the letter X, which is obviously not in the word teeth, and then basically saying, okay, letter X, you're not there at all, so we're just going to give you a square value. All right, now, what this next one is basically doing is saying, okay, what if the letter is present, but there are no remaining slots available, which is what this is doing right here. If there are no remaining slots available, well, sorry, you get this. So basically what this is saying is, like, let's say this guessed letter, now I know this is not a real word, but let's say this guessed word is I. So, which is not a real word, but let's say it was. If it was, then, and we ran this, then the code should say, okay, we didn't get any of the right letters in any of the right places because we have all the I's. Well, let's do T's because that was a T. Okay, so what you could see here is we got T in the right place here, T in the right place here, and so no, something definitely went wrong here because that should not have happened. So this is correct. This is correct. This is correct. This is correct. But it basically like just skipped over this piece entirely. So that's interesting. If And well, let's look at the remaining letters dictionary. Okay. Less than or equal to 0. Okay, my bad. So less than or equal to 0. Right, so we would have had... All right, so let's try that again. Because basically what we're saying is if this equals to 0, then we don't want to surface it, but we actually want it to be anything that's less than 0, so we actually had a negative value there. So let's try this again. So run all these again. Okay, this is actually correct now. So you can see here the letters T, 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 or T, 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 and I actually didn't even think about a spell check thing in here, but I don't know how hard that would be. So for now, we're not even going to worry about that. But you can see here, we got the green square correct here, green square correct here. Oh, something is a miss. Something is a miss. Oof. I didn't even think about that. Okay, yeah, we have another logic error here. Because we're doing basically a direct check here, and we're kind of skipping past the idea of because we might have to split this into 2 different for loops, because basically we want to catch all of these first before we do any of these. All right. Yeah. Okay, well, let's see if we can... All right, this is why we test stuff out, folks. Performing logic to match guess for check for precise. Okay, I'm going to take out this comment then. Performing logic to check for any remaining letters that might be right but not in right spot. Okay, so let's try this again. For oops, didn't mean to do that. All right, let's try this again. Okay, now this is, I think, working. All right, so this is and maybe we'll talk about unit testing another time. But basically, what unit testing is you create a couple different test cases, and then you have your logic created. That way, if you ever you adjust your logic, and then you have these test cases run and to automatically ensure that what you're doing is correct. So basically, what I did here was, well, let's talk about what we're doing. So we are doing a so first of all, we need to run through the whole thing gamut here to see like if there are precise matches. So basically, if there are all these precise matches, then we do all this loop. Then we go back through and we want to check to see if there are any remaining letters that might be correct but not in the right spot. So first things first, if we've already checked this space, so basically we're saying, all right, if we've already done a matchup here, we don't need to do any more checks down here. So what this continue thing here is saying, okay, just go to the next iteration of the loop. And like I said, Well, let me just go ahead and show you something really quick here. Like let's say it actually is break. So let me go ahead and run all these again. Then you can see that the guest letters, nothing ran after that. It's basically saying, okay, well, we already did our check here, and we hit one green square, so we're not going to go any further. So we want to go back to that word continue, because the word continue is not having us break out of the loop. It is having us continue along throughout the rest of these things here. So okay, so we are skipping over, or we're continuing through the loop if we've already seen the letter. So this next one here is, so we are, if the letter is not at all in the remaining list, so like I said, the letter X here is not in the word teeth, then we give it the empty square. Now let's say, the letter is present, but there's no more opportunities for where it could go in the slots. Then we again surface the empty square there. But let's say we do have a scenario where, the letter is present and there's a remaining slot available. Then we want to decrement that appropriately here, because basically saying, okay, we're going to turn this one gold here in our next line of code here, but we don't want, next time this goes through the loop here, we want to make sure that there is not an available slot here anymore. So if we actually look at the dictionary value here, you can see that, we have no more value. Well, do we have? Here, let me change this back to our standard one. Okay, so you can see here that teeth, because we had 2 letter T's, we only have 1 slot available now. We had 2 more slots for E's and then 0 more slots for H's. Now, granted, and this is after we have run through everything. So I actually think this code is actually working now. And then if we wanted to, all right, so how to join, all right, Python join list of string into one string. Okay, what's the simple way to do that? Join. All right, concatenate join. Oh, I'm seeing something called join. Join. All right, list. All right, so blah 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 blah. All right, so give me an example. All right, so words list. Okay, so blank.join. Blank.join. Alright, so final result equals dot join the guess letters, and then let's print final result. Okay, so that is it. This is basically what we would surface back to the end user. So let's try this out with an actual word. Okay, so the word crown. My guess word. Yeah. Okay. All right, let me go ahead and comment this out for now. Well, I'm going to keep my guess word in here, but let me go ahead and comment this out for now. All right, so if I run the rest of these cells once again, you can see here. All right, so how correct is this? So the correct word is crown now, and it's basically saying, okay, I have this word thick, and it's saying I got, so the letter T, there is no other letter T, so that is correct. Letter H. Letter H, there is no other letter H, so that is correct. Letter I, there is no other letter I in the word crown, so that is correct. Now, here's the interesting one, is the letter C. So, in my guess, thick, I do have the letter C correct, but it is not in that position. You want it to be at the start of the word because the word crown starts with the letter C. So this is actually working as expected. So let me go ahead and run this again. All right, so this next word was ultra. So, again, no T's, or there is one T, but it's in the wrong position. There are no H's, there are no I's, there are no C's, and there are no K's in ultra. So, all right, so far so good. And then let's do just another one, just to make sure that everything is running okay. All right, so legal. So legal is, it's got 2 L's, it's got an E, a G, and A, and it does not match anything, and so that is correct. And let's just do another one for fun. Quote. So quote, Quote. So the letter T is in the letter quote, in the word quote, but it is not in the correct position. It should be in position 4 there, or index position 3, if you will. And so yeah, this is all working just fine. This is okay, so this was actually the hard part, and I apologize again. Oh my gosh, I can't believe I've been going for an hour and a half. I apologize that it took me so long to think through this whole thing. I just keep getting tripped up on this. So again, I want to do another check here. So the word thick, so loans, T, so the word letter T. Did I not? Oh, I didn't run the last cell correctly. That's why. All right, so that would be correct. All right, so let's try this again. Craps. Okay, so the letter C is in the. All right, so yeah, this is all working just fine. So basically, yeah, this is the meat of the logic of creating a Wordle thing. And then the only thing that we need to do next is, and we're not going to do it today, is just figuring out a thing that basically says, okay, you get 6 guesses. And then also figuring out a thing of how to actually, I don't know if we're going to create a web UI, if we're going to turn this into a command line interface kind of tool. It actually might be fun to do the CLI just because I've been wanting to learn how to do that myself. So I think we'll go ahead and call it a day here. But this is the meat of the logic. So, I mentioned in the last live stream, like, the guy that created Wordle sold it to the New York Times for like $1 million. This right here, my friends, is $1 million idea. All this little bit of code right here, this is the $1 million. Well, I guess there's more code up here, but it's, so all that to say, not that much. So like, even though people are like, well, he didn't seem to get that much money. Sure, he didn't get that much money compared to, because I think the New York Times even reported like they've gotten so much money from this acquisition, and this guy only got $1 million of that. Okay, so what? Theoretically, that guy should have been sued anyway, because it was an original idea. Like there was a game show in the 2000s, and I think it's actually going to be resurrected and hosted by RuPaul called Lingo, and Lingo is basically the exact same thing as Wordle. So like he should just, I don't think he's ungrateful at all. But for the people that are saying like, oh, he should have asked for more, yeah, I don't think so. I think he should be happy that he got the $1 million because this is a pretty simple thing that he coded up, and it's not even an original idea. So. Yeah, I'm surprised even the New York Times was able to purchase that, because I'm surprised like Lingo just didn't sue the heck out of them for that. Well, now I'm curious. Let's Google it. Lingo, Wordle. Yeah, I knew it. Wordle kind of rips off Lingo. A copy. Oh, okay, never mind. Yeah, a copyright lawyer apparently says it's okay. I would have thought that would not have been okay. Oh, well, that's all for today, folks. I hope you enjoyed this live stream, even though it was a lot of just me waffling, trying to think through the logic of the stuff. But, I just wanted to point out here that learning Python is not too bad. And then when you know the basic things of Python, you can create a $1 million idea. So, well, let's go ahead and end it here. Thank you all for joining me. Hope you all have a great rest of your Sunday, and we will see you in the next live stream. Thank you, and goodbye. The basic things of Python, you can create a $1 million idea. So, well, let's go ahead and end it here. Thank you all for joining me. Hope you all have a